As you saw in the previous video, which was notes on how to use the quotient rule, which is basically used when you're taking the derivative of a function where it has a function on top divided by a second function on the bottom. So we can say this is the high part, high and low. So high and low, so we had like the saying low d high minus high d low over low squared down the bottom. So what I did here is just to show is the notation f on top, g on the bottom. So low d high minus high d low over low squared, low times itself. So g squared. So when I look at this function here, so the derivative, that's my f, that's my g. So I have g times f prime, so 3x to the fourth plus 2 times the derivative of the top. So the derivative of 9x minus 5 is just 9 minus the top times the derivative of the bottom. So the derivative of 3x to the fourth plus 2 is just 12x to the third, all divided by denominator squared. Okay, that's the only calculus. Now the rest of it's just algebra, just cleaning this up. So what I'll do is I'll just distribute. So I have 27x to the fourth plus 18 minus 108x to the fourth minus 60x to the third divided by, now when I square this I use Pascal's triangle. It's squared, so it's 1, 2, 1. So 1 square the first, so 3x to the fourth squared is 9x to the 8th. Multiply these two together and double it, so 6x to the fourth doubled. And then square the last term. And that ends up becoming your final answer just about, so you can simplify this a little bit. So we have 27x to the fourth minus 108x to the fourth is going to give you negative, let's see, negative 81 x to the fourth minus 60x cubed plus 18 divided by 9x to the 8th plus 12x to the fourth plus 4. And final answer. So again, the only calculus, bottom times derivative of the top, minus top, derivative of the bottom, divided by bottom squared. And that's it. That's the only calculus part. Okay, second example is natural log of x divided by x. Okay, so number 2, so the same thing applies. Derivative is, so ho d high, derivative of the top, derivative of natural log is 1 over x, minus high d ho, and derivative of the bottom, so derivative of x is just 1, divided by ho, or low squared, x squared. So when I simplify that, x times 1 over x, which means y prime 1 minus the natural log of x divided by x squared. And that's it. See, not much to it, not too bad. Okay, number 3. This one's going to get a little bit more involved. X cubed times cosine of x. So as soon as I write this, you see it's a product. So you have a product rule inside a quotient rule. So x cubed times cosine of x divided by 4 to the x. Okay, so we'll use the same quotient rule. All the difference is we have a product rule inside of a quotient rule. So two parts of this. So derivative, do a quotient rule first. So low d high. So low at the bottom times the derivative of the top. So the derivative of this mess is going to be its product rule. So product rule, derivative of x cubed, keep the rest, plus derivative of cosine, negative sine, leave the rest. So that's just low d high minus high d ho. And derivative of 4 to the x is natural log of 4 to the x. And divided by denominator squared. That's it for calculus. That's it for that part. Now it's just simplification and algebra. See if we can clean this up a little bit here. So when I clean this up, I distribute the 4 to the x. Okay, so distributing the 4 to the x, I have y prime 3x squared, 4 to the x, cosine of x, plus negative, so just minus 4 to the x, x cubed, sine of x, minus x cubed, 4 to the x, cosine of x times natural log of 4. And we have 4 to the x squared. Now when you do 4 to the x squared, remember you take a power to a power, you multiply. So this is the same thing as 4 to the 2x. Okay, you can write it like that. However, if we look here, every single term has 4 to the x in it already. So I have 2 of these, and every one of these terms has a 4 to the x in common. So technically you can factor a 4 to the x out. So 4 to the x, I can cancel it with one of those going, and that's it. So my derivative is going to be 3x squared cosine of x minus x cubed sine of x minus x cubed cosine of x natural log of 4 over just 1 4 to the x power. Okay. Alright, and last problem, we look at number 4, which again is the same thing as the one you saw before, where I have a product rule inside a quotient rule. Okay, so I have a product rule inside a quotient rule overall. So same thing. Low d high minus high d ho over ho ho. Obviously. So low, so high and low. Low is natural log of x. Actually, I'm going to start this over here. Natural log of x. So low, d high, so taking the derivative of this entire numerator, which would just be a product rule. So product, derivative of 5x to the 4th, 20x cubed, leave the rest, cosecant of x, plus derivative of cosecant of x, which is negative cosecant of x, cotangent of x, leave the rest. So that's low d high minus high derivative of the bottom, ho. So 5x to the 4th cosecant of x, and we're going to multiply that by the derivative of natural log. And derivative of natural log is 1 over x. So I multiply this by 1 over x. Again, some number times 1 over x is going to be that number over x. So basically I just put this divided by x like that. Okay, so, and then all of that divided by the denominator squared. Natural log of x squared. Okay, see if we can clean this up a little bit. What I'm going to do is distribute natural log across. So I have natural log of x times 20x cubed cosecant of x. So 20 x cubed natural log of x cosecant of x plus a negative, so just minus natural log of x. Oops, I forgot 5x to the fourth. 5x to the fourth natural log of x cosecant of x cotangent of x, then minus this piece up here. Now it's 5x to the fourth over x. So this x is going to cancel and make that x to the third. So minus 5x to the third cosecant of x. Oops. All divided by natural log of x squared. Now, can I cancel natural log out? Let's see, does every single term have a natural log in it? The answer is no, so it has to stay natural log squared. And there's your final answer. Okay, I hope this helps along with, in conjunction with the other video in teaching and explaining how the quotient rule works.